So this talk is called Perl via ink, paper, metal, and oil, and you'll see how we get to that from these machines, and a little elbow grease too. I want to give special thanks to the Salt Lake Perl mongers who organized this, the Open Source Foundation and the Transistor Group, and of course Mountain Land Applied Technical College. So we're going to have a pre-launch check. If you're here to learn in-depth Perl, you're going to be disappointed. We'll eventually get to Perl, source filters, KCAD, Modulicious, CPAN modules, but that'll be later. And we'll cover a few other things first. So a few introductions. My name's John Whitney. I got a BS ECE, which stands for Electrical and Computer Engineering degree in 1980, and I'm still programming today. I got two technical assistants. We have Stephen. He's on a local machine, and we have Brian, who's on a machine that's actually tied to the internet, can actually send email, which we did earlier, to a gentleman on his iPhone. And I have an administrative assistant, Joyce, and she'll be helping us with our world tour in 2015. So, what was the genesis of all this? There was rumblings about 2 years ago, and the question was, would it be possible to mix old and new hardware and software in a useful way that even my kids could use? And just as a show of hands, who here prior to today knows what or knew what a teletype is? So I see 4 hands. Who has seen a teletype working? Let me see 2. And who has used a teletype in their work? Well, I actually used them in my first programming job. There were teletypes around, and we used them occasionally. But that was a long time ago. And who here is a member of a company-sponsored club, like a ski club or a tennis club or something like that? Anyone? You'll see how that's important when we get later in the presentation. So my goal was to see if I could get this talking to the cloud, the internet, so where you could get news, wiki information, weather, send and receive email. And what we're bridging here is actually 50 years of technology. This machine was actually launched in around 1964, actually a year before that. And we're now looking at 2014. So what are we going to cover? The process to get everything working, some computing history along the way, and for some of you this will be nostalgia. In this room, probably only me. For others, a window on past computing. And then we'll do a demonstration and interspersed with a couple of words. And at the end, we'll actually let you come and use these machines and send an email to yourself if you want, and try out different things. So the components of this whole project is I have data terminals talking to converters, which then allow me to talk to a Linux box. That Linux box has special software that then allows me to talk to the internet cloud. So the terminals, I restored 2 electromechanical teletype data terminals. For the converters, we use both off-the-shelf and some custom hardware, and I'll show you how we design that. Linux was standard CentOS, which is like Red Hat, and we're using a basic Dell system. And for software, we did various programs and a lot of off-the-shelf stuff, such as Bash, Perl, CPAN, Modulicious. And then at the end, there will be a demonstration talking to the internet. So let's first talk about the data terminals. Why teletypes? The company was filled with engineers. It pushed the electromechanical technology as far as you could really push it. And their designs were pure mechanical marvels when you look at them. And they were really the first I/O devices for computers, both the minis and micros. And they'll still function 100 years from now. And the reason is because they're primarily mechanical, electromechanical, with very little electronics. And Teletype was a fun place to work at, and it was an employee-centric company, and you'll see that as we go on. And you can compare that to some of the companies you work at today. For example, Teletype had a day called Family Day, where they would invite all their employees to bring their families to show them various things that was going on. You can see various activities here. This is a funny picture here, because these little kids are actually using, these are IBM key punch machines, so they don't have anything to do with Teletype, but they were at Teletype, and they're actually also mechanical marvels, and I can see why the kids are having fun on them. So I'll present more slides on Teletype later in the presentation. But first, let's talk about the data terminals. I needed to be able to print, type, and punch and read paper tape. The paper tape allows you to save programs and read in programs. And it's actually a form of memory. I wanted two machines because I have two kids. They have to be identical so that the kids don't fight. You know, this one's got a better one than that one. And they had to be relatively light so they could be moved up and down the stairs. For me, portable is under 70 pounds. So what was available? In the garage I had these two machines. These are KSRs, which stands for Keyboard Send and Receive, but they don't have the paper tape mechanism. This machine was actually used at Lawrence Livermore Labs in California on their, what was it called? I can't remember. It's a famous time-sharing system. These two machines are 35 ASRs. That means they're automatic send and receive machines. But they weigh over 225 pounds each, and they're a little hard to move up and down stairs. And these two machines are 33 ASRs. These are actually the first machines that Bill Gates had his first computing experience with. And these have paper tape punch, readers, printers, keyboards. They have everything we need, and they're relatively light. So, but these two, which were under the stairs at my house, they needed to be restored. So, what does it take to refurbish one of these machines? And I'll show you that. I'll show you some roadblocks that I hit and a few tips along the way. So first of all, where can you get these machines? Well, they occasionally show up on eBay. This was in March of this year. This one showed up. It was not in working condition, and it sold for $2,300. And if it was in working condition, it might sell as much as $3,500. But about, I would say, 10 to 20 of these show up a year, either on Craigslist or on eBay. 10 years ago, they were going for $300. You know, almost you could get them for free, basically. So to restore it, there's no guide. You just basically have to use common sense. And the first thing you do is you completely take it apart and clean everything you can find, looking for anything that's out of place, missing, broken. And for example, this belt here is all cracked and would have to be replaced. That's going to break soon. So this is what it looked like when I first took it apart. This little gear here, I don't know if you can see it, but there's a missing tooth. So where do you get a part? I had to replace that. You can't run it with a missing tooth. And so it pays to have a spare parts machine. And I had a friend, I saw this come up for sale on Craigslist, and a friend of mine in California was nearby, and I said, look, go pick it up. It's $50. I don't care what condition it is. And so he did that, and then when I visited him one day, a year later, I picked it up and brought it home. Turns out it was a very good machine inside. But if you don't have a spare parts machine, you need to know this man. This is Paul Sembura. He's in California, and he's been repairing these machines for 40 years. And it's amazing what he has. He has literally millions of parts that are just all cataloged by numbers, which is another amazing thing about these machines. Every part in this machine has a number. And if you know that number and call this guy, there's a good chance he has it. And if he doesn't have those parts, he has tons of knowledge. He has books here that go about twice this far. And all these are Teletype books all the way back to like 1930. This is an example of the keyboard. We're just looking at the side of the keyboard, and the keyboard in these machines is mechanical with over 100 oiling points. But the key is you want to make sure that you don't get oil on these contacts. When the keys go down, they push these metal things out, and they're hitting these metal tabs, which are creating the electrical signal to send the ASCII character that goes out. Here I restored the feet. Somebody had spray painted them with silver paint, and all I had to do was get it off because it's actually nickel plated steel. They're actually quite nice. Then I had to re-ink the ribbons, so I did that. That's a real messy job. Then you just start putting it all back together. One of the tricks I use is, if you notice here, there's a little bag, and as you're taking it apart, you keep notes, and you write down, step 37, I took out 7 screws, and they're in bag 17. So when you're putting it back together, you're at step 37, you pull out bag 17 or whatever, and there's your screws. You know exactly, nothing's lost. And you can just throw the bags in a box, so it doesn't take a lot of space. Another trick is to use movable devices to put them on. So you can spin this machine around. So if you're fixing this, then you want to look at that, you just spin it around, and you don't have to worry about putting it on your workbench. And the kids were getting curious. What was going on? What were these machines going to do? This is that same machine, all restored now with a brand new belt. I didn't know how to put it in, but I sent out a word to the Teletype people, and they emailed me back saying, this is how you do it. Take care of this. It's a fun community. This is the inside of the machine after it's all back together. These are the code bars, as they're called, and they actually go up and down to actually spin this head, which is then hit, and it prints the character on the page. All mechanical. This is an example of one of the manuals that shows you how to oil it and grease it. And in each Teletype, these two machines, there's over 500 oiling and grease points. For example, on this one, we have D, which means keep dry, so don't put any oil on the belt. O is for oil, and then another one is G for grease. So everything is O, D, or G, and this is just half of one page, and there's 50 pages of this. So here I am oiling it, testing it, making sure it all works. I did have one problem with this clutch. I had a whine sound when there was a gap, and I sent out to the community, and I said, look, what's going on here? There was no consensus on how to fix it other than to replace the clutch, which I didn't want to do. And it wasn't affecting the operation, so we just left it. But you try to fix as much as you can. And I basically have it working now all together with the cover off. And then I put the cover on, and it's almost as good as new. So now I'm going to show you how to restore. That was Stephen's machine. Now I'm going to show you how I restored Brian's machine. Yes?
Wasn't that when you installed? I think I have an idea on what the problem on my machine is now.
You think it's the clutch?
Yeah.
Okay, thank you. Well, anyway, with the restoration of the second machine, I'll go into a little less detail. And it happened to have been a newer machine, and it was really a pleasure to go through because it was so new. And I'll do one historical tangent as we're doing that. Here's the keyboard with cover off, and you can see how mechanical it is, and each one of these has an oiling point. You don't want to drop anything on the keyboard when you have the cover off. It's really hard to line up all these keys again. And most of the parts were washed in the kitchen sink. That was Wash Part Central. This is that same side keyboard, but they had actually created in this newer model a plastic frame to keep the oil off those contacts. So as you go through the newer machines, you'll see some upgrades. This is the keyboard after it was cleaned up. This is about as new as you get. What's unique about these keys is this white plastic actually goes down about, I would say, 1/4 of an inch. So as you're typing and wearing this key down, the letter never goes away. So a lot of keyboards nowadays, in fact some up here, you use them after a while and you can't read the keys because you've worn off the paint. So for the first award, I want to ask you guys a guess what you think this might be. This is from Teletype Corporation. And what do you think it might represent? I'm open to guesses. Yes?
A dating guide for the people who work there.
A dating guide, okay. Who else has an idea what this might be? These are Teletype employees, and this is in about 1963. Yes? The fastest typist. Good guess. Any other ideas? Yes? Employee number, okay. Okay. Any more guesses? Okay, so it turns out it was an employee beauty contest. And Teletype Corporation had a contest every year. So who said the dating? That was the closest. Why don't you give him an award? You get 25 punch cards.
I get the sexist award.
No. These are punch cards. These are punch cards from Los Alamos National Labs, and they make great bookmarks. So as you're reading a book, just pop them in there. Those were used to do inventory at the labs. So anyway, each year Teletype had a beauty contest. And it was called the Telepal Queen Contest. They had 6,000 employees. They would nominate who they'd want, and they would usually get about 150 nominations. And there was a Telepal board for the contest that narrowed it down to 10 finalists. And the finalists would then tour the factory floors and visit the cafeterias so that the employees could meet them. And then the employees would vote for the 5 finalists they liked. And then the 5 finalists would attend a ball, which the company had every year, and where one of them would be crowned as queen, Telepal Queen for the year. And you might ask, well, what were they doing this for? Here's an example of this year's. This was in 1962, where they're actually touring the factory floors. And you have all the employees, watching, looking. Then this was at the ball. This is another year. This is, I think, 65. And this lady, she won, who's seated. And one of the perks is you got your picture taken, and it was put on the parking pass so that when you drove into the company parking lot, or if you're driving around Chicago, they say, oh, there's a Telepal Queen sticker. That person works at Teletype. So it was to help create some sense of community at the company. And this is actually what the sticker looked like that you would put in your car. And this was from 1962, and this was actually a decal. So you wet it with water, and it would go on the back of your windshield. And so this girl won, and this is actually a press photo for her that was in the Chicago Daily News. And then she became a representative of the company and would tour customers and be in news articles. Here she's touring a radio station. And then here she's actually visiting the set of Bozo the Clown. I don't know if you guys remember that show. And Teletype Corporation used to rent this gentleman, Ned Locke, who was the ringleader of Bozo the Clown, at their Christmas party every year that they did for children. So that was just a little historical tangent on Teletype Corporation. But anyway, this is the second Teletype, now completely restored and in working condition. This, I want to point out, is the bell. Stephen, can you go into local mode and do Control G and let them hear the bell? Do it a bunch of times, like 10 times. Okay, now turn that off. But anyway, that was used many times. People would send a message with 10 bells, so it would go ring, ding, 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 almost like a telephone ringing. I mean, that bell is basically the same as what you used to find in the old telephones. So for the next award, and for those of you to know, don't answer, but what is this part? This is in the Teletype. And what do you think this part does for the next award? 25 IBM punch cards. Any guesses? What's that? A guide. Okay. Yes? An oil filter. Yes? Eliminates hanging chads. That's really good. That's good. Who else? Any other guesses what this device might do? And it's in every one of these teletypes. Well, it turns out it is the answer back here is key key. And there's a key on the keyboard called Here Is. And when you press that key, Stephen, can you show them? Turn it on and press that. Go into local mode. Hit the Here Is key. Hold it a little bit. Basically, it prints out up to 20 characters. There's actually 20 characters you can print on here. And this is ASCII. You know, ASCII is 8 bits. So these pins, you knock off these various pins to do various letters. So if I've programmed it so it prints his name and his name. So when he wants to sign a letter, he just puts the Here Is key, and it prints out his name. The way it was used is that when you would, there was a key called, I can't remember what it was, but when you sent that signal, the machine would cycle this and send you who it was there. So you could tell if you were talking to a particular machine. So when you dialed in with modem, you'd send that signal. It would type back, you know, XYZ machine 3. And you'd know you were talking to that office and that machine. So it was a semi-communication, identification, and security device. And you can see it's installed down here. It's a little hard to see, but it spins down there, and there's little electrical contacts. And when he hits the Here Is key, that's cycling and sending that signal out. Oh yeah, give it to the what were the guesses again? I don't think there was one that was on. The hanging Chad one, I think, should be the winner. Who? Give it to the gentleman who with the hanging Chad eliminator.
What's hanging Chad eliminator?
Later. So this is the second machine, all buttoned up, ready to go. And this was an ad that came out with this product when it was released in 1963. And one point I want to make is this was the first ASCII device that they had. Before that, they were working in what was called the Baudot world. And Baudot was, let's see if I can find it here. It was a 5-bit code where you had, you know, 2 to the 5th is 32 characters, but they had a shift key or a character to go between 2 sets. So you actually got 62 characters. But if you think about it, with 62 characters, you really can't have upper lower case, because upper lower case is 26 times 2, that's 52. And then you have 10 numbers, 62. You couldn't have comma, open paren, close paren, or anything. So when they had Baudot, they were only uppercase machines. And so that's why everybody wanted to get to ASCII, which had 128 characters, so you could do upper and lower case. We take all that for granted today, but back then it was not taken for granted. This is an example of all the different character codes, and there were actually about 100 in use in about 1960. And you can see where there, you know, was IBM, UNIVAC, RCA. There were some DEC in here, Burroughs. But they were all using different codes, binary codes, to represent different characters. So it was great confusion. And so when ASCII came out, it was a standard. Took a few years to get established and flushed out. But then companies promoted it. And Teletype created these punch cards. See if I can operate this a little better. That showed you how to read the paper tape in ASCII. And in this example, if you wanted to look at the letter L, the way you would read this card is you would look at this column. Here's an L. And then you would look here. So this would tell you that these have to be on. And then you could recognize, reading your paper tape, oh, that's an L. Yes?
So do they have a way to upgrade older machines, or would you buy new ones?
No, you had to buy a new one. There was no way to upgrade. And you could get these machines in Baudot, but they really weren't sold. These really became ASCII machines. And they produced about 700,000 of these, this particular model, the 33. And at the 500,000th machine, they actually plated the machine with gold and put it in the museum. And when they actually got to the 600, I think it was the 600,000th machine, it was 1976, and they painted the machine red, white, and blue, and they took it on tour for the U.S. Bicentennial. So I don't know where that machine went, but it would be interesting to see that one. So let's talk a little bit about the data converters. We got these machines, they're now running, they're working. We now got to get to the internet somehow. So the teletypes talk in 20 milliamps current loop. So you have 75 volts, let's say, on and off with 20 milliamps. It's either on or off. With RS-232, you have a plus or minus voltage swinging between minus and positive. So we got to get to those. Plus, we have a speed change. We got 110 baud here. We want to go 300 or 36 or 9600 here. So the first step is to get to RS-232. So basically, we have the same baud rate, a passive device, and I used an off-the-shelf device for that from Black Box. It costs about $270. It's a lot of money, but you can get them on eBay for 75 bucks. And you just plug them in and it works. They're workhorses, so I use that. But now I got to get from the Black Box to the Linux machine, so I built a custom device. And what I needed this device to do is convert 110 to the other baud rate. I needed it to convert uppercase to lowercase. When you type here, you get an uppercase A, but when you're on a Linux machine, almost everything's lowercase, so you want to automatically convert everything down. And vice versa, when things are coming back, you want to convert it back up. I wanted to allow any character to be entered in hex form, so if there's keys that are missing here, you can still enter that code. I wanted the user to be able to define a function key, similar to the here is key. I wanted Control C to be handled locally. When you're on a Linux machine, you hit Control C, you might be in a long command that had already sent hundreds of characters, and they're slowly printing. You don't want to wait for that to stop. So you want to kill this printing immediately while you send the signal to the host computer. So you want to handle Control C locally. And then you have an issue of different stop bits on one side versus the other. And the teletype cannot type certain characters. For example, it has no vertical slash. So you want to maybe convert that to an L or an I so that when something prints out, it looks closer to the real thing. And you want to auto-force carriage return at the end, because these do not, if you start printing beyond 72 characters, it's going to keep printing forever in that one spot. So you want to have it return. And you got to give it time to get from one side of the print head to the other, the carriage to the other. So you have to put in a delay. So you either got to add extra characters or wait based on how far you are. And this device can do either of that. So I needed a little help on the hardware, so I went to Elance, and this was the little blurb I sent out there. And I actually found a gentleman who was local, just 5 miles down the road, and he helped design a simple data converter. And he laid it out in a program called DipTrace. And then I wired it up. This was the first hardware project I'd ever done. So I built this little prototype board and wired it up. And the main chip is the Atmel Mega 328. It's the same chip in the Arduino, which is very common. And I originally thought I was going to use the Arduino software. And this is a basic block diagram. The character comes from the PC. It's translated. It's put in the TTY type buffer. We have the same process coming here from the TTY to the computer. Then I have some escape command processing, which might do some local stuff. And I allow them to store stuff in memory to save some typing. And so originally I started with Arduino, but I found it was very restrictive. They take over a lot of the capability of the Atmel chip. And I wanted to use a high precision clock to do timing and so forth. And they were using those, and I said, this isn't going to work. So I went to Atmel, and I downloaded their IDE, which was like 10 times better than the Arduino. But I had never used one of these before, and it took me a week to find out that this little green button is the download button. I was looking for a download command, install. I couldn't find it. But what that button does is it compiles your software and downloads it into the chip. But it took me a week to figure that out. Rather embarrassing. But I really like this design. When you press that button, 2 seconds later, it's in the board and on the chip, and you can test your software. So it's a really fast way to do development. So in my software for that chip, I was going to use the UART which is a standard serial device to talk to computers. And it has interrupts, so I'm using that to talk to the Linux computer. I used a main polling loop on the TTY side. So that means I'm just got a main loop that cycles. And this Atmel chip is fast enough that I'm getting about 50,000 cycles per second, which is fast enough to do that accurately. And I use the CPU's 16-bit precision clock to create the software timer. And it turns out that lets me time up to 37 minutes. Then it's going to overflow. So what I do is at 17 minutes, I turn on a flag. And if I'm getting close and I find I'm in a pause, I then reset the clock. And that's worked out quite nicely. Then I use the EEPROM as a memory drive to hold the user-defined shortcuts. And that's, you got to design that so you have, if you have holes, you use up the holes, you do mapping and repacking. It's almost like managing a hard drive, but a very small one. So here I got everything working. I'm using these IBM terminals to simulate the teletype and the PC on either side. So I could type here, it'd go through the unit and come in the other machine. These are actually excellent. This is just a simple side note. These terminals are great. They, from IBM, they go together with one screw. This is the clicky keyboard. This is very famous. And they emulate 10 different terminals. The Atom 3, the Atom 5, and a bunch of others. So they're very useful, and they're very robust and reliable. So if you need a terminal, look at the IBM 3151. Another thing that was fun is you could get these devices on eBay for like 25, 30 bucks. This is actually a data line analyzer, so you can actually type and you can have it looking at what the signals are coming across, what the ASCII character is, whether it's working, and it allowed you to do some of the quick debugging. These machines were thousands and thousands of dollars, but you know, nobody wants them anymore, so you can get them for like 25 bucks. I had a problem with hardware X-on, X-off control, so I used software version of that, and that worked out well. Then I took that, once I had the software done, I relayed out the schematic in a program called KCAD. I didn't know dip trace, and it was a commercial program, and I wanted to be able to build my own boards. I didn't want to pay anybody money, and this was a free program developed in Switzerland. And it then lets you design the board, lay everything out. It's a little hard to use, but once you learn it, it's very easy. In fact, even Stephen used it to do his science fair project. And here's a board he did in KCAD. We'll just pass that around using the same program. What's nice about this program is it lets you see the board in 3 dimensions with the components there. And this actually let me see an error. And it turns out I had a gap here, and by moving this around, I noticed that gap, and it was a broken via link, which I then fixed. So then we took the files, we sent them off to China, and 20 days later they arrived. And I think I paid an average of, I think, $100 for 10 boards. So then I took the components and put them on the board, and this was the first board I'd done, so I didn't know what to expect in trying to debug the hardware. So I'd planned a whole day, and it turns out it took me 2 hours, which I thought was fast. And I had only one big mistake, and that I had the leads on the voltage regulator backwards. And so what I did is I unsoldered it and then soldered a new one in upside down. So if you notice, the voltage regulator is underneath the heat sink. Normally they're on top. But I have it upside down, and it worked just fine. So then I put it in a box. This is just the standard box that I bought. And finally it's done. And that was not easy. So then, now I've got the terminals. I got a converter box. Now I need to talk to a Linux system. Yes? Yeah, you can pass out. That's the board that is doing the data conversion. And for the Linux system, I just used a generic Dell. This is like probably a $5 5, 6 year, probably even older, 6 or 7 year old computer. You can get these very cheap. And I just installed Linux, the CentOS version. And there's nothing special here. It's just a standard Dell machine. And I put in a couple serial boards. So on the software side, I wanted to scrape a couple sites to get news, weather, wiki information. And I did that using Perl and Modulicious DOM Traversal. And I'm going to show you a couple examples. Let's see if I can do this. Let's see if I can scroll this. I can. So this is, we're looking at the weather program you can see up here. And what it does is it goes to weather.gov. Let's see if we can see where it's actually going. It's going to, it's probably at the top there somewhere. Here it is, forecast weather right there. So that's the URL. It's a standard. It's just government. It's free. Anyone can scrape it as much as they want. And then down here, I fetched the website. This is all being done with Modulicious User Agent. Then I'm looking for various things in the file, and you can see here I'm grabbing things. This is like a UL. This is a class, and so I'm just looking for things in that file and extracting the information, then wrapping it up and displaying it. And if I run this program, and we are connected to the live web. And the same thing will happen on the teletype. When the kids type in weather, it immediately gives the weather that is here locally. So instead of using this computer, they can use this on the teletype. And you guys can try this when you're there. Type in weather and you'll see that. And there's different options. So let me just show you another program. Let's go to news. Let's close this. Let's this is an example where here I'm looking for this. Here left starts to. So here it's up here. So with Modulicious DOM Traversal, I can search for things. And then once I'm there, I'm looking for these links. So here I'm grabbing them with, let's see if we can find that. I think I got to scroll it to the right. See right there it is, the find A. So it's very simple. So I looked for that, and then I looked for all the links, and it puts them in an array, and then I loop through the array. And that's an example where I'm actually scraping the Drudge report. So when you run this on the teletypes, it's going to print out the Drudge report. And so here's the news headlines, top of the heap. This is all new, recent from just today. So then I have the 3 columns. Column 1, column 2, column 3, but it's all in textual form. So you don't have to have a browser. You just type news in the teletype, and you get all the information from the Drudge report. And there's a couple other programs we'll not need to show those. They're basically the same thing. So let me switch back to the presentation. So that was my scraping software that I wrote. Next, I wanted the machines to be able to do a Perl program. And that's a little trickier because the teletype does not have some key characters. It doesn't have the open and close brackets. It doesn't have the tilde. It doesn't have the vertical bar. And it doesn't have the back quote. And I needed those they're key to Perl. So it would have been hard to program in Perl without them. So what I did is I used mapping capability of Perl, which is called source filter. And this is an example of doing that. So when you do bracket B bracket, I map that to a real bracket. If I want to OR, it maps it to this. So this is how it's set up. That's just a comment. Here's the actual code. It's very easy to set these up. And then I just map it here. I actually let them do either a bracket or parentheses. Either way, it works. And all you got to do is include one line in your code to get this to be used. And so I'm going to show you an example of that. Here's a little program that uses this one line, which is my TTY filter. And so you'll notice here, instead of open bracket and close, it has these things, which is E for end, B for beginning. And so the question is, will this run? And it actually runs. And when you run this program, using that one additional line up there, it prints this out. And you might say, well, what is this? And this actually tells me what pins to break off on my here is key. So if I wanted to have it to say John Whitney, it tells me which pins to break off. And it's really hard to do because you make one broken pin, you got to basically throw it away, or you do a rub out, and then it looks funny as it's printing. And those are hard to get these days. They don't make them anymore, but I'm thinking with 3D printing, they'll probably be able to make those soon. Okay, so we've got scrape sites we can program in Perl. Then I used a bunch of standard utilities, and you can see these programs run on the Teletype. And then I had it set up so that we can send and receive email. And you can actually send a message. Here, Brian can show you or let you do that. And then there's some games that we put on the system. So now we got everything running. The kids needed a manual. So I created a manual, and let's just click on that real fast. This is a manual. It's all on the web, so they can click on any one of these. So it just goes on and on and on. So this is actually, if they want to learn how to do the news program, they click there, and there it is. If they want to know how to run the calculator, there it is. So it goes on for many pages, but it tells them how to do everything. So now they got a manual. You want to hand that manual out, Stephen? Okay. And so then it was about, I think, March this year, I finally got everything working. It was talking to the web, the things were printing, the converter was working. I had enough oil to make everything work. I had paper. I had the ribbons inked. And so this was March 8th. And this is showing, this is when that Malaysian airliner went down, the news I was getting. And you notice, here I just type in weather, and I get my weather. Here I just type in news, and I get the Drudge Report. So what you saw in those programs is now working on the Teletype. So then the next thing I did, yes?
Want to show him the function?
We'll show him fortune later. He wants to know if we should show you the fortune. That's another command. You can type fortune and you can get a little fortune. I then trained the kids on how to use the system, and so they could use it on their own. And here they are howling with laughter. They're running a doctor program where it acts like a little psychiatrist, and you can actually run that program and try it out. And you can now see we got printouts showing up everywhere. Okay, so that's how we got everything running. Now I want to just share a little bit more on the Teletype Corporation and some of the unique aspects that they had from a long-lived technical firm that's no longer here, but what it was like when they were around. So you might ask, well, how were teletypes used? And this is in the 1930s. This would be an investment office. Here's an early page printer. These are old ticker machines. Teletype made a couple of these, but Edison was doing a lot of those and other companies. What I think is kind of interesting are these lamps, which are very futuristic looking for that period. Here's an example of teletypes being used at a phone company. This is a switchboard. People could call in and say, I'd like to send a telegram to so-and-so. So she would then type that telegram. She would dial the number, type it off. These are actually teletypes in front of each lady. This is another example of teletypes. This is around 1943. This is on a military ship. They would get commands and could send commands. A lot of these teletypes were used in what's called radio TTY. What that does is it takes the signal, turns it into a radio signal. It would go to another ship. A lot of it's encrypted and decrypted. And then on the other ship, it would decrypt it and then print it on a teletype. And I want to show a little few pages of Teletype Advertising.
We forgot to show him the Here Is.
Okay, show him the Here Is. He wants to show you the Here Is wheel. Yeah. This is an example of an ad. Some people say, well, how are these used? Here they're imagining you'd use it for order processing, billing, production scheduling, you name it. This is their ad. And, you know, when I saw this ad, all I could think of is Mary Tyler Moore just very happily, you know, pulling off the invoice. But it was interesting how they advertise these machines. Here's another one. I thought this ad was very well done. And I actually have one of these models, and I plan on installing it into my kitchen. And for many of you, you might realize that's a double entendre there. This is actually a wall mount machine, and my plan is to get it so that every morning at 6 o'clock in the morning, it's got the Drudge Report printed out in the news, so I don't have to do anything. And when I hear it running, I know it's time to get up.
Yeah, maybe wake us up and then we'll get mad at you.
This is another example of an ad they did. They're showing the 3 teletypes at the Space Center, and I think they were stretching it here because this is all electromechanical stuff, and they're pushing it, I think. Another thing they did a lot of advertising of was trying to convince people that teletype was always referred to with a capital T. And I thought my kids would get a kick out of this one. This is almost like Charlie Chan, man who forget initial cap on honorable registered trademark like teletype, no longer #1 son. And if any of you have seen old Charlie Chan movies, that's very close to what Charlie Chan is always saying. So let me just show you a little bit about the company. The company actually made all the parts for these machines. Rather than being horizontally, they were very vertically integrated. They made everything. And here you see them bringing in raw materials. These are just tons of sheets of steel and brass and nickel. They had a place in the plant that all it did was run 24 hours a day, every day of the year, nickel plating small little parts that they were building. Another thing they did is they had a suggestion program, and every month they handed out awards to employees who made suggestions. And the top award in 1963 was $1,500, which is about $11,000 in today's money. So imagine if you had a suggestion and you got an $11,000 check. Another thing they did is they celebrated engineering. And every year they celebrated Engineering Week. They had presentations, and then they had a big banquet of all their engineers. This is in '67, and they had about 500 engineers at this banquet. They also, the employees did creative things. I thought this guy was interesting, and I liked his title, Computer and Peripheral Operations Section Chief. And here he is explaining how they manage a computer system at that company and running all the peripherals. In those days, you know, they would have an IBM 370 or 360, and everything was timed when your job was going to run. And this guy is explaining his system of operating the computer at the company. Oh, sorry. This gentleman here was using these teletypes to type in pictures of the presidents. And they actually sent this to, I think it was Johnson, and Johnson's had his secretary send back this letter saying, thank you very much for doing these pictures on this teletype. And this is actually the letter that was sent out. Now, you know, this is all done instantly, you know, just quick scan. They can do this in seconds. This guy did it all manually. And another thing Teletype had was a board of just all their clubs. They had so many different clubs. Look at this. Photography, radio, badminton, ski, junior achievement, vacation tours, evening classes, bowling, science fair, hobby show. I mean, the list went on. So this was just the board to organize all their clubs. Here's an example of every year they did a hobby show, and they had all the employees bring in what they did. as a hobby. Here you can see this guy making boats. This guy's doing shortwave radio. Here, these ladies are doing graph analysis. I didn't know what that was, and somebody told me it was handwriting analysis. They're all dressed up to do that. This guy was collecting shark teeth. Can you imagine your company doing an employee night and somebody bringing in shark teeth? They also had a chess club. Now, for the next award, this is the third award. I want you to guess what this is. For 25 IBM cards. Yes. What's that? Marksmanship Club, okay. Any other ideas? What this might be? Well, it turns out this was the Illinois Bell rifle team. So it didn't have anything to do with Teletype. But this gentleman right here is big in the Teletype community, and he's helped me a lot, so he sent me this picture. But they actually would compete and shoot competitively against the Teletype gun club. And at that time, many companies had gun clubs. You had the IBM gun club, you had the Illinois Bell, you had the Teletype, and they would have meets. In fact, Teletype had multiple gun clubs. They had the long rifle, they had the short rifle, they had different clubs. This is in 1965. They also did a fashion show every year. This one was attended by 300 people. Yes, give the award to the gentleman in the back in the corner here. Now this is another example of the employees. The company had an evening school, and all these employees did this art that they had learned from that school. In addition to art, these were some of the courses that were being offered in 1967. You had sketching, painting, modern math. I thought that was funny. Electronics. They had cartooning. Can you imagine learning cartooning at your job? They had knitting, beginning Russian. I thought that was interesting. Bridge and screw machine theory. Math and slide rule. Don't need that course anymore. There's actually a lot of theory behind. Teletype made all their own screws. And they had special machines, and they made literally thousands and thousands of screws. And they had rooms at Teletype which would just be filled with little bins of all these little parts. And it was kind of like the creative room. An engineer could go in there and pull out screws that he think he might lose, or parts or levers or whatever. And they made them all themselves. So that was teaching the people the theory behind screws. Yes? Yes. Yeah, Heathkit. Yes, Stephen.
Is your timing okay?
Yes, timing's good. Heathkit, in those days you could buy kits. And these are electronic kits to make a radio, to make a television, to make, let's say, a waveform machine, to make almost anything. And Heathkit was probably just teaching you how to solder, how to read the instructions, how to put something together, and encouraging people to build their own electronics. Then there was a company called Heathkit, and they had, I would say, thousands of different kits. And they went out of business, I want to say 30 years ago, 20, 30 years ago. But that was a big company. But the whole kit business went out of favor, and nobody makes kits anymore. Very few people do. Yes?
Do you know if the employees taught the classes, or just like knitting, guitar?
That's a good question. I don't know who taught them. I know it was all sponsored by the company, and my guess is some of them did. I know that they had a photography group, and it was all the entire local employees. And when the company did photo shoots, for example, the fashion show, they had the company photography club do everything. So there was a lot of employee involvement in all this stuff. Here's an example of the Teletype Choral Club, and they actually got together every Wednesday and practiced in the company auditorium. And here it shows that they were doing a 2-hour show for a 500-bed hospital. And their next performance was at the Tool and Die Institute graduation ceremonies. So imagine your company, you know, having a graduation ceremony for Novell down the street. Or the Mountain Land Applied Technical College. They also had an annual picnic, which was very famous, with clowns and races for all the employees and executives. So then what happened to Teletype? Because it eventually went out of business and is gone. So it was basically shut down in 1990 by its parent company. It was owned by Western Electric. It was bought, I think, by Western Electric near World War II. So the question is why? And it turns out it was multiple reasons. They were a subsidiary of Western Electric, and they really weren't allowed to chart their own course. They were always second fiddle to the Bell system and Western Electric. There was also an antitrust decree which said that the Bell companies couldn't really get into data processing, and Teletype felt it was important to stick to that. So they tried to do everything in the communication business and not in the data processing. And they had a lot of over-reliance on complicated mechanical stuff, which they were very good at, but that was becoming, antiquated and out of favor. And they invested in technologies that just didn't work. They had an Inktronic printer that they spent a lot of money, and it ended up being really a disaster. They also started to integrate, manufacture their own integrated circuits, and this took a lot of capital and did not make the parent company happy. And the parent company itself didn't know what it was doing. It would buy a company and sell it along with other businesses, and Teletype just never seemed to fit in. And then there was the success of the fax machine, which really eliminated the need for this. It was much cheaper to just send a fax. So it was closed in 1990. And this just gives you an idea. This is AT&T. These are all the Bell companies, New England Bell, Illinois Bell, Michigan Bell. And then they had the Bell Labs, Long Lines, Western Electric, and AT at the top. It was just a huge monolithic company. And here's Western Electric, and here's Teletype. Less than 1% of the whole picture. This is headquarters that Teletype had built in 1960. This was near Chicago. They had another big facility in Little Rock, Arkansas. And this is that same building. 1998, they tore it down. And this is actually the grand staircase. And many pictures were taken of the Telepal Queens and so forth. But one of the employees went over there and took some pictures when they were tearing it all down. And it's now a shopping center near Chicago. So if you want to contact me, my number is 77.04. And you might be asking, well, what am I going to do with that? What you do is you add that to pi, and you get this number. And if you look at that closely, that is my cell phone number. So all you got to remember is 77.04. Add it to pi, you can call me. So that's my cell number. That's my email. And if you want to see pictures of the whole process of restoring these machines, it's all online at that URL. And I want to thank a lot of people who helped me. These are people all over the world that did various things, helped me along the way. For example, this gentleman is a professor in Minnesota. He wrote a book on the Atmel machine. Very helpful.
What's the fourth award?
Fourth award is right here for the best question.
Oh.
We're at the end now, so does anyone have any overall questions? Yes?
So essentially these are just terminals, obviously.
These are just terminals, yes.
Is there a limit how many you can get going on one box?
What do you mean by one box?
Like on one Linux box?
There's no limit because each one is a serial port. So as long as you have 100 serial ports, you could have 100 of these all talking, and they can all be logged on at the same time. And they're taking almost no bandwidth. I mean, you could have maybe 1,000 if you had that many serial ports. I just bought simple 2-port boards, but you can buy boards that have 16 ports, and you could probably put 10 of them in there. Yes? Am I going to sell these? Probably not. Actually, the plan was to build these machines so that my 2 kids could use them in their bedroom and could get on the internet, send email. They can actually send email from these machines, receive them. And we've actually wired the house with Cat5 cables so it can all be done. Any other questions? Yes?
Does that main motor run the entire time the machine is on?
Yes, that main motor runs, and it's got oil on those wheels, and there's oil all over this machine, so the whole room starts to smell like oil. And you get 5 of these in a room. Yes. Yeah, when you press that key, there is an electrical signal, and then it spins a disc, and then that sends it out. But it sends it out as a serial signal, but it's called current loop. So it's just turning a voltage on and off. But yeah, it's a serial signal. It's all mechanical, yes.
So you should write Perl programs on there.
Right.
But you're typing it all in capital letters, right? That's being converted
To lowercase, right.
So you don't have any control.
Yeah, I do. You mean how could I do it uppercase character?
Right. That was the question. Like, the first thing I thought of was using a CPAN module that's capitalized, camel case.
Yeah, let me just show that real fast because I didn't cover that, but it is here, and I can show it quickly. If we scroll up here to the top, let me go back. There is TTY link, and if you look down here, I have some escape commands. So, for example, escape question mark, if he types that on that keyboard, in fact, Brian, why don't you do escape question mark. Do an escape and then a question mark. Are you online?
Yeah.
Let me see, that should, sorry. Escape. Oh, I see, let's go to local. It's sending it to the host computer. Shift question mark. I'm not sure why that's not doing it. There's question mark. There it goes. So what it's now doing is it's printing out this help list. So escape will bring out this list. Escape any letter will do an uppercase of that letter. So normally it's lowercase. You just hit escape A whenever you're typing. It's going to send a capital A because you might need those for a bash command or whatever. And then escape A through Z sends out a shortcut that you can store locally. 3 escapes will send an escape. You've got to be able to do that. What's nice about escape is it doesn't print. So it's very easy to just go escape, and it sends it to the host computer. And then I let you do escape / and then any hex value. So you could send any ASCII character. And escape command lets you go into command mode, and then I have all these other commands to create shortcuts and so forth. So let me go back. Did that answer your question?
Yes.
Hooray.
Any other questions? Yes?
You might have already covered this, but why? I mean, like, what caused you to decide, hey, you know what, I'm going to take a teletype.
A man needs a hobby, okay?
No. I get it. I appreciate it. But just what caused you to decide that this was the project?
Well, I have a lot of teletypes. I have about 25 teletypes at home. And, it's like, who wants to learn programming if you're not going to write a program to do something? It's really hard to learn a language. So I said, okay, what can I do with these? It would force me to use these machines and learn. Well, that's a good question, too. But they're fascinating machines. I mean, come take a look at this, like, for example, this print mechanism for the 28. It's amazing what they can do. And it's almost like watching a fire when they're running. When you're looking into the flames, it's mesmerizing. And so you have the oil smell, you have the clickety smell, you have the mechanical, the touch and feel. You have nothing on the iPhones. And, nothing is remembered. When he types, it prints out. This paper will be around 100 years from now. But with iPhone, you have nothing, ever. So that's one reason. But there is no real good reason. There's just something fun to do. And I'd rather do this than watch TV or read the news. Yes? Any other questions?
It was actually part of teletype.
So who had the best question? Probably that last question. Why? So why don't you give the gentleman there 25 cards?
Boy, everybody was laughing at him.
That was a good question.
With him.
I was laughing at him.
Okay, so now we're going to do the demonstration. There's a few rules. First of all, be gentle with the machines. Don't type 2 keys at the same time. They're mechanical. There is a lock in there, but you can, it's easy to overpower these machines. Ask before you push an unknown button. And don't type in a malicious shell command to take over the system and create a kernel panic.
I pressed the bait button.
And if you want to send an email message, for example, you can email on this machine that's connected to the web. All you got to do is say mail, your address. It'll ask you for a subject, and you just start typing. And if you enter a single dot on a line, that ends the message, and it sends it off. Yes? There actually is a backspace. There is a feature in Linux which lets you define all those characters. I haven't set it up properly for this machine because what it should do is maybe repeat the character or do a crosshatch. Right now it actually works, but it doesn't visually show you that it did it right. So you can actually do Control H. So if you typed in your, an N here, you do Control H and then an M, or it will work. So there is a backspace in there, just not visually very, very nice. So that's it. Thank you very much. Yes, one more question. Yeah, I have a couple other pieces of hardware that you're welcome to look at. This is an interesting device. This was used in the military to add, similar to the Here Is key, those little dials that we spin around. What this did is before a message was sent out, there's a little wheel here. This is their Here Is wheel. And it pre-coded the message and then added a number. And you can see a number dial. So like in New York, if they're sending 50 messages to Chicago, at the end of the day, they can say, okay, I sent you 50. How many did you get? Well, I only got 49. But anyway, it sequenced the numbers and added an identification. And there would be banks of these. There would be 3 and then 3 and 3, one for each city, one for each line. And these were used in what was called a store and forward network. So a tape would come in over a line, and it would say it's going to go to Chicago, and it came from Philadelphia, and it gets to Minneapolis, and they put it in the Chicago bin, and it goes to Chicago. So similar to the internet now, you could send a message all over the world through this tape. It would take 20 minutes to get to all the various. And it was mostly used by the military. But just like we send messages now on email, this is how it was done, in the 1940s during World War II. And then this machine is the print mechanism for an earlier model, which I will show next year. Any other questions? Well, thank you very much, and you're welcome to come up. This one, again, is online. This one, you can see it run locally and try things. Thank you.
I'll try it.
They're in, they give you the wiring diagram of the test equipment.
Early test automation.
What's that?
It's